So, light chapter, CBQ's few questions are very like different. First time you'll experience it also, as I already told you. So let us start with the first question now. Two convex lenses, P and as well as Q, have focal length 0.5 meters and 0.4 meters respectively. So both are convex lenses, they are saying. So convex lenses means both powers are what, everybody? Powers are positive or negative? Power is positive.
Positive.
Convex means focal length is positive. Power is also positive. Now, which of the following is true about the combined power of the two lenses? So combined power means we all knows the formula. What is the combined power formula, everybody? P1 plus P2.
P2.
Yes. So they have given focal length actually. Focal length already given in meters. As I already told you, if the power is given in meters, you have to use the formula 100 by F or 1 by F. Everyone, 100 by F or 1 by F. Directly you can use 1 by F. If power is focal length is in meters, you can use 1 by F. Focal length is in centimeters, you can use 100 by F. So 1 by F divided by F means 0.5. 0.5 means can I write 1 by 2? So which is equals to 2. So power is 2 dioptries. First one. Second one is 1 by F. F is equals to 1 by 0.4. 0.4 means how much? Yes, please. 0.4 means I'll write 10 by 40. Sorry, 10 by 4. Is it right, everybody? So 2.5. Am I right, Hari? All of you?
Yes, sir.
Yes. So 2.5 it will come. So that is what it is, 2 dioptries. So I'll write it 2 dioptries plus 2.5 dioptries, which is equals to what? 4.5 dioptries. So what is the correct option? P is equals to 4.5 dioptries. P is less than 4.5 dioptries. P is more than, P means combined power. And P cannot be determined from the information given. So what is the correct answer, everyone? Option?
1.
Option 1. So combined power they are saying. So remember combined power, if focal length is given in meters, go with 1 by F. If focal length is given, if the focal length is given in centimeters, use the formula. What is that, everyone? Power is equals to 100 by F directly. So no conversion, nothing. Okay, so do it fast, everyone. Next. Next question is little important question regarding refractive index. So everybody make it. When an incident ray of light enters a medium from air and it will bend towards the normal. So we all knows that it is entering from air means air is having a least refractive index. What is that, everybody? Air is having least refractive index, which is equals to what? All of you. 1. Am I right or wrong? So if every other medium, the refractive index is what? Refractive index is greater than 1 only. So it is entering from air to some other medium and it is bending towards the normal. So we all knows that entering from optically rarer to optically denser. So it will bend what, everybody? It will bend, speed it will bend towards to the normal and speed also decreases. So which of the following is true about the refractive index of the medium, some medium Nm, as compared to the refractive index of air? So what will be, everybody? Definitely it is more than, yes please. The refractive index of any medium is definitely greater than refractive index of air. Why? Because who is having a least refractive index? Least refractive index for whom, guys?
Air.
Air.
So that is why every other medium, the refractive index is definitely, it is greater than air. So option C. Option 3 is correct. So refractive index of a given medium is more than refractive index of air. So that is what you have to remember. Always a refractive index of any medium is greater than refractive index of air. That is what we all know. So please make it. Yes, completed everybody. So next question. Call to your friends. So next question you see that. This is a good question actually. So you can see here screen will never move, object lens will move. So now you see that question is really good question. So when a lens in when a lens in place at Q, when a lens in place at Q, a sharp image is formed on the screen. From this sentence, you will understand something. Can you tell me, anybody? A sharp image is formed on the screen, means in the sense of you are going to get something. Anyone get? A sharp image forms. That is what we used to call as, yes, very good. So if the lens is at Q, a sharp image formed at the screen, means in the sense of this distance is called it as a what? Anybody? What is the distance we used to solve, everyone? The distance is called it as focal length. Understand all of you? So that is what you have to remember, focal length. Now, the image formed is real, inverted, and diminished. Okay. When the lens is moved to P, another sharp image is formed on the screen. So, when the object is, when the lens is moved from P to Q, imagine just, Q to P, another, when the lens is moved to the P, means from Q to P, another sharp image is formed on the screen. So now they are asking, what is the nature of the image formed when the lens is at P, they are asking. So another sharp image it is forming. And what is the nature they are asking? So anybody can tell? All of you? Yes, please. Yes. What is the nature of the image formed when the lens is at P? Anyone? So first, all of you tell me. So we all knows that if the distance between the lens and the screen, suppose imagine this is the screen. So now if this is the focal length, so we will get, of course, in between this range. This side also what will happen? Everybody, this side also focal length is same. Am I right? All of you, please respond, guys. This is F2 and this is F1. Do you remember, Hari? All of you? Yes, please. Everybody? So if I take a
Yes.
lens, actually we are having a 2 points. What is the points? Anyone can tell? What is that points? All of you. So midpoint optical center, and this side we are having F1, and this side what we are having? Sorry, here F1 and here F2, and at the equal distance we are having what? 2F2, and here what will we be having? 2F1. Yeah. All of you? Yes, please respond, everybody. So now be very careful and observe and tell me. So now you observe, imagine that the Q position is now this. What is the Q position? Here. So here is the Q position. All of you see that. Here is the Q position. So now light is coming somewhere. Now image is forming on the where? Screen is at where? Everybody? Where is the screen? Screen is at F2. Am I right, everyone? So that it is forming the image at this is what? So what is the characteristic they are saying? The image is actually a real, inverted, and diminished image. Real, inverted, and diminished image. So real inverted and diminished, there is a case for us. Anybody can tell what is the case? Real inverted and diminished image. What is the case? Any one of you? Yes, Amma?
First case, sir.
Real inverted and diminished. When the object is at behind, when the object is at, see, object is at where? Here, object. So when the object is, try to see your book and tell, when the object is at behind 2F2, 2F1, when the image will form between F2 and 2F2. Remember everybody? So what is the characteristics of the image? Real, speak guys, real, inverted and diminished image. Check it everybody. Case number what, Hari? Case number 2, I think. Is it right? Verify.
Yes, sir.
Yes, Amma?
Yes, sir.
Yes. So please remember real, inverted and diminished image. It is a case number 2. When the object is at behind or beyond 2F1 means when the object is at here, you can see that. When the object is at here beyond 2F1, then the image will form between real, inverted and diminished image. That is what is that happening. So this is what we people are making. Now all of you observe very carefully. So now what they are doing, they are just shifting. Distance will never change. Now they are shifting the lens from object is remains at the same position. Now the object lens alone shifting from, check it everyone, from P to Q. Sorry, Q to P. This is what. Now if the lens is coming here, then this will become the optical center. Then this will become the F2 and this will become the 2F2 and object is at here, this point will become F1 and here it will somewhere another distance it will become what? 2F2. Do you understand everybody? Sorry, 2F1. Is it right or wrong? Please respond guys. Everybody? Yes? So before object is at beyond 2F1, now object coming to 2F1 and sorry F1 and 2F1. Now image will form where? Anybody? Beyond 2F2. So what is the characteristics? Real, inverted and magnified image. So what is the options? So once again I will explain you. I know that many people not understand. So once again you see that. So first they are saying that you just imagine the only the first case. See that we are having convex lens means totally how many focal length we have guys? How many focal length we have? All of you? At least that you tell. So we are having two focal length. Am I right everybody? So middle optical center, principal axis, F1, F1, 2F1 and here F2 and next one is what everybody? 2F2. Yes, Ra, at least that we can. Okay. So now all of you observe very carefully. So now object is at somewhere. Object is at somewhere so that it is forming the image on the screen. It is actually a real, inverted and diminished image. So by reading these three, real, inverted, diminished. So what is that actually case? So case number 2. All of you see case number 2. Hey, if not interested, leave from the meeting. Otherwise, you respond. So case number 2, what will happen? When the object is at behind 2F1, object is at behind or beyond 2F1, then what is the image will form? Everybody. Image characteristics. It is real, inverted and diminished image. So object is at 2F1, behind 2F1. So image will form between F2 and 2F2. So that is what is the characteristics real, inverted and diminished image. Am I right everyone? Clear everybody? Is there anyone or all are like? Now they
Yes,
are
sir.
saying, now actually this is the optical center. Optical center is this. Now imagine that Now lens instead of here, it is shifted to F1 position. So now I will draw here. That is what a P. So now this is the optical center. Then this point will become what actually F1. So object is still here only. Object is still here only. Then actually we all knows that distance is equal. So then what will happen? The Q point will turn up into F2 and F2 point will turn up into 2F2. All of you understand? So now what is happening? Object is still there. Object is now here F1 means then behind somewhere 2F1 will be there. So object is at same position now. Now what will happen? Object came to F1 and 2F1. So image will form at where? Image will form at where? When the object is at F1 and 2F1. Everybody?
Beyond 2F.
Beyond 2F2. So that is what is the characteristics, real, inverted, and as well as what? All of you. Magnified image. Okay. So that is what you have to remember. So it is you have to work out. There is no way. So options you can see. Diminished and upright. See, I can go with elimination option also. All of you observe. Convex lens. In one case, it will form virtual and magnified. Can you tell me what is that case, everybody? Virtual and magnified image. It will form in one case. What is that case? Case number? Case number 6.
6.
So that is also what is the characteristics? Virtual and magnified image. Am I right? So magnified and upright. Upright means erect image. But here they have given diminished and upright. So I can remove this. Next one. Here magnified and upright. Of course, magnified and upright only case number 6. Means object is between F1 and 2F. Sorry, optical center. So optical center and F1 it is not possible. So this option also we can, because object is already placed, you can see somewhere behind the focal length. So next one is diminished and inverted they are saying. So diminished and inverted, what will happen? First case it is when the object is placed, it is real, diminished and inverted. So when case number 2, now the lens is shifted from P to Q, object is still remains same. Please remember everybody, basically we will move the object, but here they are moving lens. So that is what you have to remember. Lens is shifting from Q to P. So optical center shifting from Q to P here. So now P actually become optical center. So then 2F1 will become F1. Then somewhere it will come 2F1. Then this side F2 become, what will happen? F2 become 2F2 and before optical center will become F2. So just image object position is remains same. So lens is shifting to that. So the characteristics it will become what? Real, inverted and magnified image. Sir, still not understand? Anybody having doubt, you can ask. Once again, I'm ready to explain. If not, you can proceed. Do you all clear, everybody? Harish, understand?
Yes, sir.
It's very simple. Basically, for you, you all practice that object will move. But here they are giving lens will move. So that is what I'm saying. So based upon the characteristics given, you should identify all of you. So first they are saying real, inverted and magnified image. Sorry, diminished image. So it is case number 2. That is what you have to remember it. Do it fast, everybody. Completed? Understand, Amma? Mitakshri? Hasini?
Yes, sir.
All of you see here. That's what I'm saying. Where is the case? Yeah. So by seeing the options, you have to remember. So what is that saying, everybody? Case number 2, see here. Diminish, real and inverted. So here also you see that. Real, inverted and diminished. So real, inverted and diminished means it is a what? Object is at where? Everybody? Beyond 2F1. Do you understand, Amma? So that is what it is. Now, It's very, that is what you should understand it. So before object is at beyond 2f1. So what is the characteristics of the image we are getting? Everyone, real, inverted and diminished image. Okay, now imagine this lens is shifted to f1. So what will happen? Then 2f1 will become f1. Then somewhere 2f1 will come. And here optical center become f2 and f2 become 2f2. So object is still the same position, image is still the same position, but as it is focal length is shifted, so here the image will becomes, that is what it is, real, inverted and magnified. So by changing, by shifting the lens from this, from Q to P, so it will turn up into case number 2, turn up into case number what, everyone? Case number 4. So that is what you have to remember. Object position, they never change it. That is the reason it is. So you have to remember. Only lens it is moving. So keep remember that. Okay, everybody? Clear all of you? Understand, Amma? That is what. Write it. Any doubt, Mr. Nimish? Understand? Google. Next. The image below shows a student demonstrating that sun rays concentrated to a point using a spherical mirror can burn a paper as a science project. So burning of paper. What is the lens? Anybody can guess? What is the lens we'll use? Or mirror they are saying. The mirror? Okay. Yeah. Spherical mirror they are saying. So what is the mirror we can use to burn the paper? We will use that mirror to use focal length also. Anybody? Which mirror? Concave mirror. Yes, converging mirror, concave mirror. Or lens means convex lens. So answer the following questions they are asking. What is the term used for the distance between the mirror and the paper? So approximately it is catching fire. So what is the distance we used to call it as? Anybody?
Focal length.
Yes, all of you? So it is what, everybody? It is the focal length, approximate distance. It is catching fire. So that what is the point we used to say? Sharp image is forming. So what we used to say? Sharp image from the mirror. From the mirror, focal length. Do you all understand, everybody? So the sharp image is forming. So that is the point which we used to say. Actually, what we used to say, Ra? Focal length from the lens. So please note it. Next, what kind of image would be formed on the paper? What kind of image will form at the focus? Yes, please.
Real and highly diminished.
Real and
Highly diminished.
highly diminished image. So here there is no real and highly diminished. So what is the answer? Option 1. Make it real and diminished image. So now a student wants to depict the above experiment as a ray diagram. Just now I have drawn. What is that ray diagram? You can see it and tell me. Option.
Option 2.
So case number 1. Case 1. When the object is at where? Everybody. When the object is at infinity, image will form at principal focus. That's all. Make it, everybody. Understand, everybody? Hussein, Mr. Naveen, do it fast, everyone. Join with the number Kaushik and Swadhan. Don't understand saying means. Make it, everybody. Right next. If the student wishes to point the mirror to another object, if the student wishes to point the mirror to another object, so as to obtain a virtual and enlarged image, Virtual and enlarge. So we all know virtual and enlarge means there is only one case. What is that case, everybody? Virtual and enlarge means case number 6. What is that? Object between pole and focus. That's all. So between the pole and principal focus. So option number 3. So where should be the position of the object with respect to the mirror between the pole and principal focus? Make it everyone. Next. Which of the following is not a common use for the type of spherical mirror used by the student for the experiment above? Everybody check it. They are not asking which is not a application of that. What is the mirror actually which is the student using actually it is? All of you? Concave mirror. So concave mirror cannot be used as a what mirror? Check it.
A real
Car headlights, yes, we are using. So car headlights, definitely the concave mirrors because they have to focus all the lights, whatever it is coming. So they have to shift it. So they have to make it parallel light because bulb will be at the focus. So they have to produce the parallel light. Next, solar cooker, yes, all the parallel light has to be focused at the point so that it has to increase. Saving mirrors, yes, we have to see virtual and enlarged image because what will happen when the object is between pole and focus, we'll get a magnified and virtual image. Am I right or wrong? Everybody? Yes, please. All of you? Yes. Then what is the only not? What is the only not? Yes, rear view mirror. Rear view mirror also we can call another name. Anybody? Side view mirrors. So side view mirrors means what is the mirrors we'll use? Everybody?
convex mirror.
Convex mirror. So that is why, which is not they are saying. So option 3 is the correct one. Do it everybody. Hope understand everyone. Any doubt anybody can ask. Clear guys? This is Sanjay.
Yes,
Yeah. Make it everybody. Swadhan, am I audible Swadhan? I'm calling you 3 times, 4 times now. Next. Next question everybody read about. All of you has to read. Guru. So the diagram below shows the image of an image of a candle. Image of a candle as formed through reflection from a concave mirror obtained on a screen. So all of you observe very carefully. First screen, what are you seeing everybody? Observe it and tell me. Mr. Pugal? Yeah. Were real, first inverted image you are seeing and then you are seeing magnified image. So what you are depicting? Anybody? Yes, please. Real inverted and magnified image. So what is that? Real inverted and magnified image. Which case? Just now we studied. Real inverted and magnified image. Real inverted and enlarged image. What is that? Object is between f1 and 2f1. So image will form where? Image will form beyond 2f2. Actually, it is a mirror, correct? So lenses I am talking. So mirrors, if I come back, so what will happen? Same case. Mirrors also same. So what will be there? Everybody. So if I have taken when the object is at, when the object is at beyond between C and F, so what will happen? Image will come beyond C. So what is the characteristics? Enlarged, real and inverted or magnified, real and inverted. So the same thing they are asking now. See here. Real, inverted and magnified image. Now, how many light rays from the point P on the candle flame can be drawn to the corresponding point on the image P? So how many rays we can draw? Anybody? Try to guess at least.
Many rays.
We can draw anything. Do you understand it? So I can draw 1, I can draw 2, I can draw 3. Infinity number of rays I can draw. So no, but basically if you want to draw the image of any object, minimum number of rays, how many? Minimum
Two.
number of rays, how many? 2. That is what you have to remember. So minimum rays is 2. Minimum is 2. So with 1 we cannot be. So from any point of the object, we can draw infinitely many. So please write it. Infinitely many number of rays we can draw. So, but basically we want it. How many we need? Minimum 2 we need it. That is what you have to remember. Okay, everybody? Yes, please. All of you? Do it. Understand, Hussein? Mr. Naveen? All of you do it next. Swadhan, you are not considered to be attending. You are cheating fellow, I know. Make it Emma, everybody. Completed. Next question, read. The eyeball of a person has become slightly larger. Now, which kind of lens should be used? My excessive curvature, sorry, eyeball size is too big. What is the lens will prefer, Amma? Yes, please. What is the lens?
Concave lens.
Yes. So concave lens. So what is that? Basically, what is the defect they are asking? Which kind of lens should be used for a person to correct the defect vision caused by this size of the eyeball? What is the defect, Amma? First, anybody identify?
Myopia.
Myopia. Understanding? So myopia we're having two reasons. One is eyeball size, eye size is too large, or the curvature of the lens is what? Curvature of the lens is what? Yes, please. What is the two reasons for myopia? Excessive curvature or eyeball size is too large. Am I right? Yes or no?
Yes, sir.
Yes. So power is not reduced because of high power it will happen. So what is the lens we'll use to correct the myopia? Concave or convex? We have to reduce the power. So we have to use concave lens. Concave lens
Concave.
means what lens? Diverging lens. That is next. The image formed by ordinary convex lens suffer from a defect called chromatic defect, which leads to the false colored edges in the images. This happens because light rays of different colors bend differently as they enter and leave the lens. If a parallel white light beam passes through a convex lens, the light of which color among violet and red in the spectrum will converge at a point closest to the lens. Justify your answer. Which will be converge closest to the lens. Anybody? All of you? So it's very important question. So please remember, I'll explain what they're saying. A parallel white light beam passes through a convex lens.